Okay, so this video is going to be about completing squares. This is going to be a complement to the first video. And then in another video after this one, I get into actually solving quadratics by completing the square. So first, let's talk about where this even comes from. So let's say we had a perfect square. So x plus 1 all squared equals x squared plus 2x plus 1. Right? So we say this is a perfect square because if we drew a picture, right, that was in, excuse my crappy art here, but let's say I had a square whose two dimensions were both x plus 1. Its area, therefore, if we do length times width, would be x plus 1 all squared. So that's where we're getting this from. The idea behind the whole completing the square thing is that, well, obviously, here in blue and here in green, these two are precisely the same. So if we cut this 2x in half, right, so I'd say this piece right here is a square, and all four sides are x, it has an area of x squared. So that's where we get this x squared from. And then if I cut this 2x in half, right, into just a 1, okay, well, these rectangles formed would have an area of 1 times x, or just x, right? And x plus x, of course, is where we get the 2x from. Okay, and then right here, this guy has a length of 1, and so does this guy, and that's where we get just a 1 from. So we have x squared plus 2x plus 1, right? And we see, of course, we get x plus 1 and x plus 1 again. We get the exact same thing. Okay, so that's why these are called perfect squares, right? Well, it comes up that you have things that are not perfect squares, right? So you guys that are in here, give me a number that's even between 2 and 12. Go. I heard 10. We'll use 10. Okay, so let's say I had x squared plus, instead of bx, we'll say 10x. Okay, so this is an imperfect square, an incomplete square, we'll say, right? It's almost a square. Okay, so if I do like what I did here, we're going to see that we have a piece missing. Okay, so let's start with the x square, right, whose two dimensions are both x. Its area, therefore, is x squared, right? And then I'm going to split the 10x in half so that I've got this piece is 5, this piece is 5, right? And we see that we're going to have 5x for our area on both of these rectangles. Okay, now we're missing a piece right here. Okay, we're missing this piece that we had on the last example. Okay, and we see that this piece missing is also a square, namely 5 by 5, whose area would be 25. So that's what we're missing to complete our square, right? But this is algebra. We can't just add 25 from nothing, right? So we have to account for that. We have to counterbalance with a minus 25. Okay, and what we're going to see is this here in purple is going to be a perfect square, just x plus 5 all squared, which is exactly what we've got here, right? X plus 5 times x plus 5 again, that gives me x plus 5 all squared as my area. Okay, and of course we still have this counterbalance sitting out here, that minus 25. This leads us to a generalization, such that if we have an incomplete square, x squared plus bx, it's factorable into uh, the difference of a perfect square and half of b squared, right? Okay, and that's exactly what we see happen, right? B was 10, half of b was 5, right? And half of b, 5 squared, gave us that 25. Okay, so now let's practice this on some actual examples. So first example here, we see an example much like what we saw in the form x squared plus bx. Okay, and that is always going to be factorable into x plus half of b all squared minus half of b itself squared. Okay, so all I'm going to do is plug the numbers in where they go. X plus half of b all squared, half of b in this case would be 4, minus 16. Okay, because 4 squared is 16. Okay, another example. Okay, so this one's a little bit different because we do have a third piece here, a constant sitting off to the side, but it doesn't change what we're going to do. I'm going to focus on this piece right here. This is our incomplete square, x squared plus bx. So that's going to give me x plus 6 all squared, because half of 12 is 6, minus 36, because half of 12 is 6, and that squared is 36. And then I still have this minus 9 sitting out to the side here. Combine like terms. Our final answer here would be x plus 6 all squared minus 45. One last example, and then I'm going to cut this video. So we have a problem here on this third example. Okay, so every time that we've been completing the square, we see here that our a term, right, our a term is always equal to 1. And here on number 3, that is not the case. Okay, and this is easily remediated by just factoring out whatever is making a not be 1. So I'm just going to factor out a 5, and we're lucky here because our GCF of all three of these terms is 5. So that leaves me with x squared plus 2x plus 3, right? And now I'm focusing on this part right here. Tell them to go away. Okay, so now I'm left with 5 times x plus 1 all squared, and minus 1, and we still have the plus 3 to account for, and we have the 5 still sitting out there unused. Then we just redistribute the 5 and combine these two like terms. We end up with 5 times x plus 1 all squared plus 2. Okay, that does it for this video. Shoot me an email if you need anything. Otherwise, goodbye.